Hi team, a very good evening to everyone. We will start the session in few more minutes. And today we have the session on basics of array and the basics of data structure and the data area. So we will wait few more minutes. Okay, so now I am starting the session on basics of array. So be engaged with the session.
And today I will cover a few topics about the array, what basics of array, type of array, and how the array functionalities will work. Okay, so please be focused on session. Okay, so first we start. So basically we do understand what is the array. So in the basic common language we or usually say array is the collection of element of same data type. Okay, so it's a group of the consecutive memory location with the same name and data type. So what is the consecutive stand for here? Basically consecutive stand for here, like we have a location the of a element like 001. So mm, the next memory location is called the 00112. So that is the consecutive memory, means the location number will change according to the storing of the array. So simple variable in single memory location with unique name and a type. Okay. Array is the collection of different adjacent memory location. All these memory location have one collective name and type. So adjacent memory location means the depend on the beside of the location, like array is storing in a one position, and beside of that another memory location is called the adjacent here. And the memory location is the array that hold the value is known as the element of array. So basically what is the element of array? So memory of location in the array called the element of array. And total number of element in the array is called length or length of the array. And the last one is that the element of array is accessed with reference to its position in array, that is called index or subscript. So what is the index? I hope you have to understand. So now we come to the next slide. So next slide is advantages of array and uses of array. So array can store many value with single name. Okay, so we can store multiple single same data type of multiple things in the single array, so we can use in program according to where we need to use. Array used to process many value easily and quickly. The value stored in an array can be stored easily. The search process can be applied on array easily. So basically, instead of declaration too many type of variable work variable, we can declare a array instead of that, and according to their index value, we can fetch the data. So array is a can easy our program work very uh, efficient way. So we can use that. This is the basically advantage or uses of advanced array. So let's move to the next slide, that is the types of array. So basically the types of array in AS400 we usually used to do runtime array, pre-runtime array, and compile time array. So basically nowadays we are using runtime array. Okay, this is the advanced type of array that we are usually used to do. And the first array we used to do, that is the compile time array. That the we will understand one by one, from the compile time array, pre-runtime array, runtime array. So basically let's understand the structure of array. So what is the structure of array? So you can see there is the length of array, that is the 1 to 7. And in this length of array, you can see there is the element a, b, c, d, e, f, g, h. And what is the indexes of array? So starting index of the array is the 1 and last one is the 7. So that is the whole structure of array. So whenever now we are going to study about array, so you easily to understand what we are going to do, and how we are playing with these length of array and with the indexes and what is the elements. So this is a very clear and clear diagram to understanding the structure of array. Now we jump on the declaration of array. So basically we have learn type of array. So we introduce three type of array: runtime, pre-runtime, and compile time. So whenever we go with this array, so how we have to declare in the program this so declaration of runtime arrays. So that is the declaration declare as, and then the type of array, name of array, and the data type, what data type we are going to use, and the dimensions of array. And for the runtime, that is the for, and the next one is the pre-runtime. Pre-runtime is the f for the file declaration, that is the flat file name where we need to fetch the array. Then that is the I for the read mode. T is the table, or for the telling the program that is the belongs to table, or that is file belongs to array. And F for the file describe file. And 240 is the basically record length of the flat file. And then the disk is this disk belongs to the, that is belong to physical file or flat file. And then the declaration of the array, so that is the D, and that is the month, the name of the array. Then the belongs to the external variable, and this 20 is the element, the numbers of record length we want to fetch from the file, and that is the dimension, and in which file we are going to fetch. So that is the from file, and the month PM that we have declared already, and the per record length, how much length we are going to fetch from the file. So we will understand what is the per record in 12 in the in during the program. So till then you do look at as it is, what is that thing. And then comes to the compile time. Compile time is the declare for the declaration, then the name of the array, and the data type varchar is the varying data type, number of 20 sets of character, then dimension, and the ct data basically tells the program that arrays belong to the compile time. So usually whenever you used to declare the compile time array, the CT data is mandatory for that condition. So basically this is the basic type of declaration. You just have a look on that. We will do understand in the clear during running the program or making the program. Now comes to the compile time array. The compile time array. So let's understand the compile time, pre-time, runtime array. What is these array? Means array is the simple collection of same data type, but why we have declared type of array. So let's understand the what is the compile time, pre-runtime, runtime array. So compile time array. The compile time array means the element of array will be loaded before the execution of the program, that is the compile time array. So whenever we declare the compile time array, so what happen, array will loaded after the execution of means when we execute the program, then after the compile time array is load, and the value will be static. It means we can't able to change the before running the program. So is this is the static hold the static value. We must declare in keyword command. So for declaring the compile time array, we have to declare keywords dimensions, ct data, and per record. So dimensions, ct data is mandatory. If you doesn't want to tell the declare that per record, so it's also work. So it's not mandatory. According to our requirement, we can also declare this keyword. So these keyword we can work with that. So this is the compile time keyword dimensions. What is the dimensions here? Represent the size of array. Ct data represent that is the compile time array, and per record represent the numbers of entry in one array. So during the declaration of array, I have told lots of time what is the dimension, what is the dimension. So and how we need to declare what is the dimension size in array. So for easy understand, let me explain you how you can declare define what is the dimensions of array. So here the dimensions how you can declare row and column. So numbers of row and numbers of column you have to work. You can multiply both of them, then you can get what is the dimensions of array. So like you are taking per record 2 and numbers of row in your array is 3, so you can multiply both of them and then you get the dimensions of the array. So it's easy to understand what is the dimensions of array. You can easily to get and you can apply on your program. Now comes to the pre-runtime array. So in pre-runtime array, we maintain the array element in a separate file. So in the declaration type, we are talking about the flat file. So basically, flat file contain all these record and all these data and all the element in a separate file. So flat file is the work as a separate file. So same thing is declaring array. In pre-runtime, we maintain the array element in a separate file. If we are making any changes in array element, we can just change in the file containing the element. Okay, if we want to change like in compile time we are holding all value in static. So in that condition, in that scenario, pre-runtime array scenario, the all the element of array is holding on a separate file, and we can change this file containing data, and then we can work on that. We don't need to compile the source program again and again in the compile time array. So that is a good part of the pre-runtime array. In compile time array, data will load after the execution. In pre-runtime array, data we don't need to compile source program again and again. We can work with the flat file, that is separate file that containing all the data. So we can go through with that data without compiling any source program. The file that stored the array element must be defined in the fspecs with the t as the file designation entry. So in compile time we usually say like we don't need to declare any kind of file declaration here, but in the pre-runtime here we can declare that file type also, where that contain all the data, all the element. So for the telling the array that the we need to declare that file, so that file is belong to that one. So that is the pre-runtime array basically. So uh, we need to tell the program that through a fspecs and with the designation. that T is told that belongs to array, or that is the table type of file. Then it's come to record length is also a mandatory entry in fspec. So record length is also, so whenever we making a flat file, so we have to declare uh, a record length of that particular file, and whenever we declare that fspecs in the file in the program, then we also need to tell what is the record length of this file. And the length of record, so usually we can say the like dimension length of record, how we can get the length of record per record and size of the element. So after the multiplying these, we can get the length of the record. Now comes to the to define the array in our program, we use to keyword from file instead of ct data. So that is the make a difference, how you can easily understand after the seeing a program key this program, this array and this program belongs to which, what kind of array. So whenever we see there is a declaration in the ct data, so you can easily understand that belongs to compile time array. And when you see the in declaration of array, that is form file, so you can after seeing you can easily say that belongs to the pre-runtime array. Now comes to the last one, the runtime array. So what is the runtime array? The runtime array means the value will be loaded during the runtime only. So what is the difference in threes, in the threes type of array? Compile time is loaded data during the execution, pre-runtime taking data from a separate file, but in the runtime we can store, we can load data on the runtime. During the runtime the value will be dynamic, means we can change data and we can load again and again our array for the new data that we want to change in our program. Some useful array related opcodes, so we can play with the opcodes too. We will discuss like loop, lookup, sorter and export. So let's see on our program how these things are work. Okay, so let's jump on the program. So the first concept means the first type of array, that is the compile time array, and then comes the pre-runtime array, and now the new one is the runtime array. So let's start with the old one, that is the compile time array and how it's work. So that is the basically declaration of the compile time array. So that is the declaration, and that is the name of array, array1, and that is the data type. I'm taking character of the number of len. That is the dimensions of array 20, and that ct data is telling that arrays belongs to the compile time array. And I have declared two array here, the array1, array2 with the same type of specification. Then that is the index, and I will let you know what is how the index is working in the program. And that is the data, that is the another standard variable I have declared with the character type, and that one is the integer type. So I'm taking the index one. So index basically tell the location of the element, we can say, like we have understand in the file also here. So that is the index basically 1 2 3 4 5 6 7. So that is the clear image, so you do understand what I'm telling to you. And I'm running a loop do while index 1 till then it's on, to the 5. Okay, so, and now displaying the data of array, and then increasing the value of indexes, and one by one till then is come to the 5. Okay, and now let's see how it's work. And one more thing, whenever we declaring the array of compile time array, so that is the area where we are used to declare the compile time array. So by pressing shift F7 we can see this area comes pop up out, and now we can see there's the three I have declared the element of our data, means record. So Hasan, Ozvik, Ankit, Yasvi, these kind of data we have populated here for the array 1, and for array 2 I have declared here. You can see, let's run to the program and let's see how it's work. So here we get the results, these 4 to 5, that is the 5. And let's see what is our program telling us to do. So the program is run to the 1 to the 5, and these data we have populated, that one, compile time array. So let's see the another example of with the per record. So I have declared one array with using per record and the indexes and data of the array data. So indexes is 1, and here the array data, and I'm trimming that data with the indexes with the clearing for clearing the spaces and displaying this program again the same in loop and the return. Now let's check what is the value of array. So what is the per record means here? So I have taken character of 20, okay, and dimensions of this array is 20, and CT data is telling that the compile time program array, and that is the per record 2. So per record 2 means like it will set up the 20 character here, 1 2 3 4 5 6 7 8 9 10. Again 10 number, 1 2 3 4 5 6 7 8 9 10. Okay, so here the 10 number is completed. Okay, and per record means one record is complete. Now again after the we need to count 20, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, so what happen here, first it will read that 20 character from here. Okay, and in the next line it will again next 20 character from here. Okay, so continue, it will continuing their read operation. Okay, if we didn't get there any value, so it will fill with the space. Okay, so let's see while running the program what happened. So so here clearly we can see the first 20 record he is reading. Okay, and again here getting 20 record, a 20 character record is blank, so it's containing a space, and he is filling blanks here like a space here, and then again it will read again next record from the 20 here, and then it will showing the as a blank space here. Okay, so let's check with some doing some editing program. So here clearly we can see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Here the 20 characters 20 set of character is complete. Okay, so now the that is the breakpoint, and here he got these number 1 2 3 4 5 6 7 8 9 10, and again 20 are filled with spaces. So you can see how the per record will work easily. So that is the basically compile time array. Now let's come to the pre-runtime array. So I have shown that compile time array in the free format, fully free format to you, but you can say there is a pre-runtime array is not support the fully free format because of the declaration of that particular flat file. Okay, so there is a no way to declare that flat file in the program in a fully free format. So you have to go through the file declaration and dspec declaration with the fixed format. Okay, so that's the limitation we can say And let's see. So that is the basically declaration of flat file. And that's the I for read mode. T is for belongs to table and array. F is the file describe, and C is the length of the record file, and D is belong to disk. So before these learning means going on the pre-runtime array, let's see what is the flat file. So basically flat file nothing, just a physical file, but the with the single record length of file. So how we have to declare the how we need to create a flat file. So just few basic things we have to choose, like I am making a flat file test file 1, and in which library you want to make library, and you need to declare the length of this file. So I'm declaring 20 length of this number, and then hit enter, and you can see clearly test file 1 is created in library. Okay, and for the seeing, you need to just run this command. So you can see there is a test file flat file has been created, and this is the number of record. Okay, and as simple you used to run command for the entering data in physical file, you can go with the same. So I have working with the flat file, the name of the flat 001. So let's see how many data he have containing. So I have the data ABC Rohit and till the 8. Okay, till the 8 dimensions. So let's see how this program is gonna work. So that is the declaration of flat file, and that is the declaration of uh, array. So what is the array name is the per pre array, and that is the dimensions of the array 9. Okay, and in the flat file you have see there is the 8 numbers of record. I have declared numbers of record is 9, and from which file we need to fetch data from the flat file 1, and that is the again per record 1. We can go with the 2 also, and that is the I is usually tell indexes of the array. And here the program in this time running with the for loop for I to element of the array. So basically element of the array is tell the size of array and numbers of element available present in the array. So the its loop runs to the element of array and then displays the result. So let's call the program. Okay. So from here, ABC, we have started reading 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there is we have took the 9 dimensions of the 9 dimensions, but we have containing only 8 record in the our flat file, so it will showing blank here. Okay, so our program is running perfectly here. Now let's come to the, I hope you do understand what is the flat file and what is the pre-runtime array, what is the compile time array. So now comes to the runtime array. So this is the basically we used to work with the dynamically in the program. So usually we use that one array. So flat file we can perform the write, read, and update operation in flat file also. Now it's come to the runtime. So that is the for the dynamic taking the dynamically and working with the dynamically in the program. So that is the declaration of the array runtime array. So that is the array declaration, and that is the array name of the array, and that is the data type zone. I have taken the zone type, data type is 3 and the starting position, and the taking the dimension is 10. And that is the I am taking for the indexes, and here I'm taking data type, zone, and number of 2 elements. So how the main program is starting here, or in the top you can see there is a control option. You can ignore it. Basically, during the debugging, we usually declare that one. That is the main program for I equal to 1 to element of array. In the same program, learning the for loop for 1 to the element of array, then array I equal to I plus 4, inserting element to the array, and I have, for the better understanding, I have declared display element of the index. It will show in which index or which value we are getting. So I hope you to understand easily during the running program. Sorry. So element of index 1 and the value is 5. Okay. Now we can see element of index is 2 and that the value is 6. Now we can see element of index 3 is 7. Till then, numbers of 10 dimensions, 10 indexes, it is showing these things. You can see this is indexes, and this is the value 5 6. So it is changing according whenever the index is increasing, means one by one is go to the next index, the value is showing here. Okay, so you can see we can work with the runtime array, how we can modify our program too much easy in a easy and efficient way. So we can go with some opcode. Okay, in the run program, here we have worked with the element opcode. Okay, and now we have to go with the lookup. Okay, so the same thing, declaration of the array, runtime array, and then the indexes, and again I have taken a work variable that is name of index. Okay, so inserting the element or value. So first we are inserting the value here. Okay, and after that searching that particular value of 8. Okay, here, so we are taking the work variable that is indexes, we are searching for the 8 in array. Okay, so for a for that, if index not equal to 0, okay, so display number 8 found or index the character, so it will show the in number of, if number of 8 index value here. Okay, if we didn't get anything, so it will show number 8 is not found. So same for the number 5, same for the number 4 between 1 to 3. Okay, so let's see how that program is working. So we can see on the numbers of index 8, we 8 we are getting 7. Okay, for sorry, for number 8 the index is 7, and for number 5, okay, there is a no index we can are available for, means that number 5 is not element in array, so we can't able to get their index. Okay, and like index we can see what is their position in the easy language, and for the number 4, we can see their index is 3. Okay, so their position is 3. So by using lookup we can also search the index of our particular value, like in a program in an array. If we are we need to find the location of that particular value, so we can use the lookups opcode, uh, lookup built-in function for the getting their index value. Okay, now come to the subarray. So we usually use to the substring, so it's usually used to substring built-in function. So for the like a substring is also a subarray also. So there is a two type of array. We have declared array 1, array 2, and that is the I and for the indexes, and I is the indexes for the work variable. Okay, so it will show display before sorting and display before subarray, we can say. Okay, then we will say after the performing subarray what is the result of that. So what is the declaration of this subarray built-in function and what is the parameter of that? So that basically we need to declare subarray, then the name of array, okay, and then the starting index where we want to start, okay, and then the numbers of element we want to fetch, okay. So here I have declared numbers of 10 dimensions, but I'm fetching only starting from number 4 or only 4 value in subarray, okay. So let's see how the So here we can see before sorting what is the value of the our array 1 2 3 4 5 6 7 8 9 10. These are the value that is stored by the array, and after the sub array performing sub array built-in function we have started with 4 and the numbers of element we want to fetch that is 4. So 4 1 2 3 4, okay, starting from 4 and taking only 4 value, and after that all the things value is getting 0, okay. So that is how the subarray is work. Now comes to the sorter. Sorter basically used for the manipulating the array, manipulating in the sense of the by arranging in order like ascending order, descending order, okay. So for basically sorter used for that, okay. So we will see how that sorter will work, okay, sorter of code. So for that first we will see how the before sorting what is the indexes and how many elements in the array, and after the sorting of array we can see how that is work. So declaration of the same, that's the program array shown dimensions of the 10 I for the indexes, and index I am taking the work variable, and here the displaying the before sorting 1 to the element numbers of element, and it will displaying this one by one, and after that the sorter of code sorter descending order and the name of array we want to sort, then it will display the after sorting and 1 2 element, then it's done, okay. So let's see. So for the using sorter opcode our indexes is like that 1 2 3 4 5 in the ascending order 1 to 10, we can say C, and after the sorting in the descending order it will perform like that 10 9 10 to 1. So how that the sorter is work. So there is a more of code you can do practice with that also, okay. This is the basic things you can you can clear your doubts how these work, and after that you can do the experiment with that. Now we are going for the xfoot. What is the xfoot? So basically xfoot tell the sums of the or array if we want to add all the element together, okay. So we need go with the sorta built-in function, okay. Sorry, we go with the export built-in function. All right. So the declaration is the same array 1 array 2, then the I for the indexes, and index is the working variable here I have taken. Display before export what is the value of the array it will show, and then the after export it will show performing the export operation and how I am taking character. Taking is all value in the character, changing dimensions to character here and displaying on the is result value, and that is the export built-in function, that is the array we want to perform the operation in which array, okay. So let's see. Before export it will showing 1 to 10, and after the export built-in function performance it will show the sum of these array after the changing the value in character. So that is the basically I am clearing the basic thing you can learn in the deep about on the IBMi website also. So these things work like that. And one more opcode is introduced, that is the for each. Okay, so for running on the character, okay, if we want to run a loop, okay, so it will show the transfers value to you one by one by using for each statement message and displaying the value. So the same thing, that is the three dimensions of array, runtime array. So basically if you want to identify what is how we can identify the runtime array, so there is a no declaration of ct data per runtime data or per record kind of these things. We can go with these things already, no declaration of any file. This is run dynamically, so whenever we see these dimensions include any declaration and these kind of things, so we can easily understand that is belong to the runtime array. So these array containing these data, okay, first index containing hi, second index containing hello, third index containing bye. Okay, let's see for each how the for each work for that. Okay, hi, hello, and bye. Okay,
So that is all about basics of array. And now we will take a short break of 5 minutes. And after that, we will have one more short session on basics of data structure and data area. So uh, please take a short break and we will meet again at 5:46. So, hello everyone, and now I am starting the second session that is based on data structures and the basics of data area.
Structures and today we will cover what is the data area and the type of the data area and what is the data structure and the type of the data structure. So what is the data area? So data area is a kind of information. A data area is a kind of storage where we can store the small information of the data, and date information can be shared by the different jobs that is running on the system. And there are two types of data area basically we used. The first is user defined data area and the second is local data area. So a user defined data area is created by a user. A user can create their own data area and can store the fixed information in it and can use it whenever he want. And a local data area is a system defined data area, and we use it for the temporary if you want to store the temporary information, so we can say it a temporary data area. Once the user will log out from the session, the information will also erased. And there are some commands we use for creating the data area, and we will see the use of that command in the programs. And now we will see what is the data structure. So a data structure is actually an area of storage that allow us to declare the subfields in whatever layout we want. So we can say it's a single variable in which we can create multiple variable of different data types. So today we will cover the different way of creating a data structure, what is the qualified data structure, and what is the template data structure, and the use of the like ds keyword and the multi-dimension data structure. And also we will cover the type of the data structure. So in today's session we will cover three type of the data structure. The first is externally described data structure, which is this data structure is created by the external source. And the data area data structures we used when we want to retrieve the information from a data area, and if we want to update and add some information in the data area. So in this case we use the data area data structure. And the program status data structures provide us the information of the program into a program, and it contain the predefined subfields with the fixed position. And for an example, like if we want to get the procedure name in a program, so the position will always be fixed. We will use the one always we will use a first position, and it will be similar for others. We will see it in the program. So first we will see how we can create a data area. So for creating a data area, we use the CRT DTA ARA command, and after that we will press F4, and here we will give the name of the data area. So let's suppose we have the data area name 1. And after that we need to give the library name and the type of the data area. Like we want to store the information character type. Yeah, or here we need to give the length of the uh, data. So here we get the length 50, and there is no need to give the decimal position because we use the character data type. And here we will insert the data. So whatever the data we will insert, like we insert sample, then press enter. So the we will see the data area is created. And if we want to see the data area, so we will use the DSP DTA ARA command, and we need to press F4, and here we will give the data area name, the library name. So here we can see the data area with the value. And if we want to update the value, of the data area, so we can use the change DTA command. And we will press F4, and here we will give the data area name, the library name. And from here we can update the value, and we can add the new value. And this is the position here. This is a starting position, and we can change it if we want, from where we want to update the information. So we can give the position here. Let's suppose we want to update the information from 20, and the position of the substring from which we want to update the information, like it's 10. So, and we want to add some new information, like simple one. And we will see it using the DSP command. The DTA1, the library name. And here you can see the new information added in the data area. So this is how we can create a user defined data area. And now we will see the local data area. As we know, it's a system defined data area, so we cannot create it, so we can directly use it. So we want to see the local data area, the same command we will use, and press F4. So for local data area, we use star LDA. This is a local data area, and we will change the library name. Okay, so there is no need to give the library name. It will automatically pick the library name. And we can see it's a local data area, and we can directly use it. If we want to add information in it, so we can use the same command, change data area, and F4. And here we will also give the local data area name, which is star LDA. And if we want to give the information in it, so we will give it in the new value. For example, here I'm giving ABC. So, and if we will see it, and you will see the information is added. So this is how we use the local data area. And if we will log out from the system, the information will also erased from the local data area. And now we will see how we can declare a data structure. So this is a data structure, and these are the subfields of this data structure. So we can access these particular field directly in the program. And I create a standalone variable with the same name of the subfields. So here you can see assign the value in the field 1 and field 2, and we will display the data structure. But the problem with this structure is that we cannot create the another standalone variable with the same name any of the subfields. If we will do it, and it will throw us a compilation error. And now I will show you. If I will compile it, yeah, we get an error. So what error we will get? Yeah. Item has already been defined on a definition. So it means we cannot create a variable with the same name twice. So to overcome this issue, we use the qualified data structure. Now you see the qualified data structure. So now this is a qualified data structure, and these are the subfields of the qualified data structure. So now the subfields are no longer can be used directly. we have to use the data structure name to address this particular values. So every subfield will follow by the data structure name, and uh, in qualified data structure now we can use the standalone variable outside the data structure with the same name. Here you can see I declared the standalone variable with the same subfield name, and also assign the value in it. So now if we will compile it, we will not get any error, and I will show you. Compile it, it compiled successfully. Now if we will run it, it will give the value of the data structure 12 and name of the field, and also value of the standalone variable. So this is the use of the qualified data structure, and now we will see what is the template data structure. So if we create a data structure as a template, so now we cannot access this data structure in the program. We cannot access the subfields of the data structure in the program. Like if we want to access the subfields of this data structure, so we can assign this data structure into another data structure. So what we will do this, how we will do this? So for this we use the like ds keywords, and like ds keyword is used to inherit any data structure to another data structure to define it. So you can see the full name is inherited by the stu name data structure, and we can see now we assigned now we are populating the subfields with some values that are followed by the stu name data structure, and if we will display it, it will display us the value of the data structure. So we will compile it and we will see. Yeah, it's successfully compiled. Now we will run it and we can see we access the value of the subfields. Okay, so this is the use of the template keyword, and now we will cover what is the multi-dimension data structure. So this is an STU data structure which has the dimension of 10, and these are the subfields of this data structure. So why we use the multi-dimension data structure? If we create a multi-dimension data structure, it means we can store uh, 10 different information of group in a single data structure. So let's suppose we have 10 students in a class, and we want to store all we want to store the information of each student in a single data structure. So in this case we use the multi-dimension data structure, and it will work like an array. So we use indexing for store the information. So here you can see we use the first index for inserting the information of first student, and storing the information of second student. We store the we use the index second index. So we can use the in 10 index for storing the 10 student, because it has that dimension of 10. So we will compile it and we will see how it will work. Okay, yeah, it's compiled successfully, and if we will run it, we will see it display the information of first student, and if we will again run it, we will see it compile it show the information of second student. So this is the use of the multi-dimension data structure, and now we will cover what is the PSDS data structure, means program status data structure. So this is the PSDS data structure, and there are some fields. There are some fields, and the position of fixed for the each subfields. As we know, the program status data structure has the predefined subfields. So now it will give us the program name and the source name and the source library and the date. We will run it. We will see all the information. Yeah, it's compiled successfully. And if we will run it, we will see the program name. And again, if we will run it, we will see it gives us the source file name, the physical source file name, and the library name and today's date. So, and if you want to know about the job and job names and other things, so you can refer the IBMi site here, where there you will get all the information. And now we will see the externally described data structure. So as we know, we declare this data structure by the external source. So here I uh, I use a PF where this PF used contain three fields. The first is name, class, and subject. So now these fields will be the subfields of this data structure. So we can use the fields of this PF directly as a subfields in this data structure. And also another way we can use it, and now we can create our own subfields, and we can assign the fields of the PF in the subfields. So in these two way we can use it, and if we will and we can assign the values with the in the fields. So here you can see we are populating the subfields with some values, and if we will run it, we will see. Okay, so we can see it's first showing the first the now we it's showing the first information, and now it show the second information. So this is the way how we can use the externally described data structure. And now we will see the data area data structure. So how we can retrieve the information from a data area into our program. So for this, you can see we use the DTA ARA keyword for it, and where we give the name of our data area. And previously we create the data area with the name, and now the this is the field 3 is the subfields of this data structure, and the information of this data area will be stored in this field in the subfields. And we use the in keyword for for read a data area. So if we will compile it, and we will see here, we get the information of the data area from our program. And now if we want to if we want to update the data area, then how we will do this. So if we want to update the data area, then first we need to log the data area by the in keyword. And here you can see I use the log keyword. And if we want to and after that if we will assign the value in the field subfield, and then we need to unlock the data area in the by the out keyword. So this is how we can add the value in the data area. So I will show you it in the debug mode, that how it will work. we will run it. So now we will see the subfields. Now the subfields has no value, and after reading the value, after reading the data area, it will have some value. So now if we will see, it contain the value, it contains some value. And now we will update the value and we will assign the value in field subfield FLD3, and we will see the value will be changed in the data area. It will update it. Okay, we will see it in using the DSP command F4, and we will give the data area name, and we will see the value is changed. So this is how we can update the data area through our program. So this is all about today's session. Thank you for attending the session.
So that is all about today's session. And now we will end this session. And if you have any query, then you can join our clinical session at 6:30. So thank you everyone for joining this session.